So yesterday we talked about right triangle trig. Today we're going to talk about law of sines. Right triangle trig is great, but it only works with right triangles because you have to have a hypotenuse. So the law of sines we're going to use to find missing sides and angles of non-right triangles. And the law of sines says this, that the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. In this formula, little a, little b, and little c represent your sides, and big A, big B, and big C represent the angles. And when you think about a triangle, the way that this works is angle A across from that is little side A. Angle B is across from little side B. And angle C is across from little side C. Now, are they always going to give you a triangle labeled ABC? No. Sometimes they're going to give you a triangle labeled RST. But basically, it's the same thing. Just know that you're going to put the sine of the angle over the side that's opposite it. So don't get hung up on the A's, B's, and C's. Just realize you're going to put the angle over the side across from it. It's opposite side. Okay, so we're going to do a couple of examples. And when we're doing these, we're going to do what's called solving the triangle, which means that we want to find all the missing pieces of the triangle. Anything that's not given in the problem, we're going to find. So, first of all, this is not a right triangle, so I'm going to try to use law of sines. So I start setting it up. So I have the 39 and I have the side across from it. So I'm going to call that sine of 39 over 40. Then I also have this 32-degree angle, so I'm going to do sine of 32 over little q. And then for the p's, I don't know either one of them. I don't know the angle or the side. So then you can either use the law of sines, or you can use your brain, or you use a combination of both. When I look at this, I know from middle school geometry that the three angles of a triangle add up to 180. So I start right away in finding my third angle. 180 minus 39 minus 32 is 109. So I already have angle P filled in before I even have to start using the law of sines. Now, will it always be that easy? No, but if they give you two angles, you can find the third one right away. Okay, so then in order to solve for Q and P, these are just proportions. So you just want to cross multiply, divide. So I'm going to find Q first. So if I cross multiply, that would be 40 sine of 32, divided by the sine of 39. And that would equal Q. So you're going to type that in your calculator. Be sure that when you do the sine of 32, that you close that parenthesis before you do the sine of 39. So divided by sine 39. That equals 33.68 approximately. So side Q, which is also the side RP, because remember in geometry we learned to name sides of a triangle with two letters. So this little q is also this side RP. So that's 33.68 centimeters. Now, when you go to find P, now that you know Q, technically you could cross multiply divide with these two. However, let's pretend for just a second you made a calculator mistake here. You have it set up all right, but somehow you got a calculator mistake. If you use this number to find P, then there's no chance you're going to get P correct. So I always tell people, always go back to the one that you knew for sure. So even though this one's in the middle, who cares? We can still cross multiply divide here. So I would do that. So I would do 40 sine of 109 divided by the sine of 39 equals P. Go ahead and type that in your calculator. 40 sine 109. Again, remember to close that parenthesis or you're going to get the wrong answer. Divided by sine of 39. And we got 60 it's 0.97, so we're going to round that to 60.1. So 60.1 centimeters. Now, I'm going to use another idea that I learned in geometry class, to kind of double check myself here. Is it perfect? Is it going to tell you that you're not, you know, off at all? No, but it'll just kind of help you. There's a theorem that you learn in geometry that the smallest side of the triangle is across from the smallest angle of the triangle, the middle side is across from the middle angle, the largest side is across from the largest angle. So you can just kind of double check that your numbers make sense. The biggest side should be across from the largest angle, which it is, and our smallest side is across from our smallest angle. The closer these two are together, the closer these two will be together. So we're going to assume that we didn't make any calculator errors and that that's the correct answer. Okay, let's try another one. So in this case, I wasn't given two angles, so I can't use my cheat quite yet. So in this case, I'm going to go ahead and I set up my proportions again. So sine of 110 over 9, because the 9's across from the 110. Sine of s over little s, I don't know either one of those. Sine of t over 7, because the 7's across from the t. So obviously this is a problem because I have two variables, so I can't do that one yet. So I'm going to go over here and do this one. So that would be 7 sine of 110 divided by 9 equals the sine of t. Let's talk about what happened there. I cross multiply divide. So this times this divided by this. So when I do that, 7 sine of 110, closing the parenthesis again, divided by 9. So that's the sine of t is approximately 0.7308. But that's not what I'm looking for. I'm looking for t. So in order to find t, just like with our right triangle trig, I have to do that inverse sine to get rid of the sine. And again, I want to use the whole decimal from my calculator. So I'm going to do second sine, second answer to bring that whole decimal down so that I don't round until the end. So I get 46.959. So I'm going to call that 46.96. So angle T is 46.96. So I can fill that in here. I can fill that in here. But I can also now that I know two of the angles, I can go back and use my handy dandy subtract from 180 trick. So 180 minus 110 minus 46.96 equals 23.04. So that means angle S is 23.04. Fill that in, fill that in, fill that in here. Now I have one of these two so that I can cross multiply divide to find the other one. And again, could you use this? Yes, but better to go back to the one you know for sure. So I have sine of 23.04 times 9. So 9 times sine of 23.04 divided by the sine of 110. Again, cross multiply, divide. This times this divided by this. 9 sine 23.04, closing the parenthesis, divided by sine 110. And S is approximately 3.75. Double check yourself again. The 110 should be across from the biggest side. The 46, which is the middle side, should be across from the middle side. The smallest angle should be across from the smallest side, which it is. Okay, at this point, you're ready to do quick checks 2 and 3 on page 802. But we still have one more thing to talk about, so don't get overexcited here. All right, there's a problem with law of sines. There's a thing called the ambiguous case, and it's created from two different issues. If you remember back from geometry, we learned about ASA, AAS, SSS, and SAS. And what those are used for is if you're given a triangle, okay, and you're given another triangle, let's just use side, side, side for example. If you know that these sides are congruent, these sides are congruent, and these sides are congruent to each other, then those two triangles have to be congruent without even knowing what the angles are. Same thing would apply if you have side, angle, side. Same thing would apply if you have angle, angle, side. Same thing applies if you have angle, side, angle. But we learned in geometry class that this bad word one, ASS, does not guarantee that the triangles are congruent. So let's remind ourselves what that looks like. If I have two triangles, if I'm given that these two are congruent, I'm giving that these two are congruent, and I'm giving that these two are congruent. So the angle and the two sides, but the angle isn't between the two sides. If the angle was between the two sides, that would be SAS, which is okay. But it's when the angle is away from the two sides that we have an issue. These two triangles could be congruent, or they could not be. So what does that mean to law of sines? That means that if you're given an angle and two sides, where the angle's not in between the two sides, there could be different triangles created. Why is that? Well, let's talk about something we learned this year. Remember the unit circle. If I have a 30-degree angle, the sine of 30 is 1/2, but the sine of 150 is also 1/2. So there are angles over here that have a partner over here. And since those are both less than 180, those could both be possible angles of that triangle. So, what does that mean to us? That means that when we are given an angle and two sides that are not the angle in between there. So let's go back and label our triangle here ABC again, so we know what this is going to look like. ABC, so this would be little a, this would be little b, this would be little c. If I was given this angle, then in order to be ASS, I would have to be given this side and this side, or this side and this side. Can't be given these two. So what do you notice there? If you have all three letters, then we're good. If you have one angle and two of the sides, and I have a repeated letter, then I could possibly be not good. But again, first we check for ASS, then we check, okay, so I have two with no angle in the middle, so that could be a problem. All right, so here's the deal. This is the formula you need to know. B sine of A is less than A is less than B. If this is true, we can have two possible triangles. Okay, so for tonight, on your ones that you're going to try, those are not going to involve this. So you don't have to worry about that. But tomorrow in class, we're going to talk some more about this, do some examples. But you just need to recognize if you have ASS and this is true, then we could have two possible triangles and we need to find both of them. Now, last thing is, it's also possible to have no solution. But if that happens, you're going to find it in your calculator, because when you go to try to find the angle, it's going to give you an error. So we don't have to worry about checking for that ahead of time. See you tomorrow.